The next step is to define the access control policies. But pretty much you need to define who's gonna access what. But at this point, you've already identified your actors. So you created the use cases and use case diagrams. And you have identified who of the actors would access which of the use cases, right? So during the analysis, you have already identified or started to identify the connection between the actor and the use case. Okay, now we need to define that at the object level. Okay, so generally speaking, a general user or a general actor would only access the data they created, generally speaking. Okay, but a higher in the hierarchy, a type of actor like an admin actor would have more access to data even though they didn't create it. Okay, so now when we were in the analysis creating use cases, you just decided the actor is linked to this use case. Now, what does that mean at the design level? So now we have objects that we decided which of them is persistent and which of them is not. Now, who's gonna be accessing these objects? Who would be able to see this data that was stored? So you need to map that. You can look at the use case and see which data, like the use case that is linked to an actor, you know which data is needed for this use case, and this actor should be allowed access to this type of data or this type of object. Okay, and also another thing you need to think of when you think about the access control, not only who's gonna access what, also how are you gonna authenticate? So how the authentication is gonna happen. Okay, so that's also a decision that needs to be made here. The next step is to select a global control flow because this determines what type of application you have. Generally speaking, there are three main types of flow. There is a procedure or a sequence-driven control. So that's like everything has to happen in sequence, like a command line application. Now, command line applications are not popular in general type of systems, like the popular type of systems, but they still exist. For example, get that we use as the source the version control system is a command line application. Well, there is a GUI that is built on top of it. It can be connected to IDEs, but the get itself is a command line application. So command line applications still exist. There is a decision to be made, so it is possible that you can choose to have your system in a sequence driven type of control, which means like, you know, in a command line application, you have to type a command and wait for the result, and then type another command and wait for the results, and so on. So it's like a sequential kind of flow. The event-driven control, all GUI applications are event-driven, which means that the application will be waiting in a loop for the user to trigger a certain action. So the user would click on a button. Based on that click, based on the button, a particular action will be executed. Okay, so that is event-driven. There's concurrency, which means that multiple actions can be triggered at the same time. The most applications that are targeted to the general audience would likely be GUI applications, which means event-driven. But the other two are still exist. And then we need to decide what happens at boundary conditions. So boundary conditions means like when something wrong happened, when a crash happened or like a network outage happened. Okay, if some problem happened, some failure happened, what are you gonna do? Okay, are we gonna restart the system? So what is the way that you're gonna handle this kind of situation. So that's something that you need to think of. What kind of boundary conditions can happen in the system you're working on, and how are you going to handle it? All right, and you can create use cases that are particular for the boundary conditions that may not be natural to the business, but they are just created for the sake of handling of this kind of conditions. So you can probably say that the admin can handle this situation in this way, and the way would be a use case. Okay, and these use cases would be called boundary use cases. And finally, before you move on to the next stage, you need to refine the subsystem services. Now, remember that we had the connection between the components supposed to be in the form of provider and requester. Okay. Now, so far of the examples that we've used, we used this dashed arrow to indicate general dependency. Now, before you move on to the next stage, you need to replace these arrows by the definition of or a more refined definition of the services. Now, towards the end of the system design stage and before you go to the object design stage, you should be able to identify at least which of the systems is provider and which of the systems is requester or requirer, and a general description of the name of the type of the system represented by the name, the type of the service represented by the name. All right, and that should be all for the system design activities. We'll talk about it a little more when we meet at the class. So see you then.